So we'll just wait for a few minutes to allow everybody to join. Okay, so any questions from previous week's content, previous week's discussion? And that is week 3. First, I'm asking about week 3. So, has everyone finished the assignments up till week 3? That due date is over, right?
Yes, ma'am.
Okay. All right. So for this week's content, you go have the assignment ready. So like any questions for week 4 content so far? Okay, no questions. All right. So so let's first just go over a few of the concepts which are covered in week 4. So I think the concept of functional unit, that's an important one. And I felt like that it might be helpful if I explain it a little bit more. So I'll first explain what is the functional unit, and then we can discuss a few questions related to the week 4 material. Is that okay?
Yes, ma'am.
Yes, ma'am.
Okay. Your voice is not coming properly. I couldn't hear what you said. Could you just repeat your question? Shajina Venugopal, I couldn't hear your question. Okay, I don't know if she can hear me. Okay, so if you are able to hear me, and if you're still online, you can ask me a question again. I'll just go ahead with first explaining life cycle assessment. and especially in the context of the functional unit. So just give me a moment. I will just set up the board for that. All right. So um, let me just share the. So I think you guys have already studied LCA, at least some part of it, right? In the previous week's lecture. So, can somebody give me a recap of what you do in LCA? Just a brief idea. Any idea? Does anybody want to help me get started?
Raw materials are extracted.
Sorry, okay. And
Materials are then processed.
mhm,
Product management and assembly.
okay.
Use and maintenance.
You're telling me the steps for what?
Life cycle assessment.
So what you're telling me is not actually steps for life cycle assessment. What you're telling me is steps for manufacturing of a product, product's life cycle. They're not steps for the life cycle assessment. They're stages in a product's life cycle. They're two different things.
Okay.
You're correct about the product life cycle, but these are not the steps for the life cycle assessment, is all I meant.
Yes.
Okay, okay. Carry on. Then,
And end of life.
hmm, okay,
Life cycle
cool.
assessment is the how you calculate environmental burden of a product service.
Yes. So, in life cycle assessment, we consider many different stages in a product's entire lifespan, which uh, impact the environment or may be good for the environment. So the entire environmental impact. So there are only 3 or 4 steps in life cycle assessment. First is you define the goal and scope. Now, I think in your lecture notes it says that this comes later, but traditionally this is how you do it. You first define the goal and scope. So I'm just sticking with that for now. Then you get an inventory. Actually, even before that, wait, not inventory. And define the system boundary. Spatially as well as temporally. Both are very important. Okay. So when you define the system boundary, then you can continue to all the next steps, which is that you do an inventory and you do the environmental impact assessment. And then you see the compare results and stuff. Okay, and in this identification of the functional unit is more or less done when you uh, define the system boundary. I'll write it separately here. After defining the system boundary, you identify the functional unit. So okay, we've done this in week 4 at least. So does anybody have any idea what we do when we define the goal and scope in life cycle assessment? What do we mean by goal and scope?
Calculating the materials, how
Mm,
it is going to be reused, or is it going to be end of life, or how much we are going to make, and understanding how n works, like for every product you make, when you are re cycling it, how much is actually coming back and how much is going to the landfill.
so all that is like a side effect of what you define as the goal and scope. Firstly, so what you're telling, I mean, it's not wrong. It's just what you're saying is like a whole lot more detailed and it comes much later. All these are decisions you will take based on the LCA, right? What you're saying that how much can be recycled and all that is true. What is the overall goal of doing the LCA in the first place? So you have to define that in a more succinct way, or in a more, it's in a few lines alone. For example, like in your case, what you were saying, it may be that you want to redesign a product to be more environmentally sustainable. So you want to measure which materials can be changed or recycled or replaced. So that can be the goal of your LCA. You understand what I'm trying to say?
Yes, ma'am.
Yeah, so you're trying to give a bigger idea behind the LCA, because anybody can do an LCA for anything. There's nobody stopping anyone. But when you define the goal and scope of the LC, that makes a whole lot of things much clearer for you also, and for resource allocation also. Then it will help you decide the system boundary. So although I know that in the lectures she's explained that sometimes it's better to do it the other way around, where you are going to design a product, that system boundary and functional unit should be defined first. But you could do it both ways. I mean, yes, you could do it that way also, but the bigger idea is that you're defining the goal as that. So if your goal is clear that you're designing a product to be more environmentally sustainable, or if you have even more specific requirements, like you want to reduce the energy consumed by the product, or you want to reduce the emissions given out by the product, and for that purpose you want to know exactly how emissions are generated or how much emissions are generated per unit or whatever, then that needs to go into the goal and scope. Sorry. Yeah. So what it is for, and in our case we can of course say that yeah, it's for design purpose. Then coming to system boundary, uh, anybody wants to explain what is system boundary spatially and temporally?
What I understood from the previous lecture, the system boundary is the what we define to get the either the final goal where we are designing, like if we say like whether it is going to cradle to grave or and the end products we are deciding. So it can be anything. So one product there will be different kind of system boundary. That is what I understood from the previous readings and all. So
Okay. So your understanding is partially correct. It's not wrong. It's just that you can make it even simpler. So when we say spatially, we mean like, for example, like in some cases, like if you're just holding a coffee mug and you want to define your system boundary spatially, it's not that difficult to do. Then you can just say that, okay, I want to look at the boundary of the system in the sense that from the time it is you start procuring the materials, from there till the time it goes back into end of life. So that is the whole picture. I want the whole thing. So in that, what all am I including? So spatially and temporally, they are not mutually exclusive. First of all, when you're defining something spatially, most of the times you will be defining it time wise also. Temporally means on a timeline. So how long is your timeline
Now connected to our 2D.
So if you're defining it, for example, cradle to cradle or cradle to gate, you are defining a timeline also, right? It's not that you're only defining the product alone or physically alone. You're defining the timeline as well along with that. So both of these have to be specified, is what I'm trying to say here, right? They both have to be specified in your model. So when I'm saying specified, for example, like I was taking the example of a coffee mug. Oh God, I'm trying really horribly. So suppose this is coffee mug, right? And you want to take it cradle to gate, for example, right? Then you will start with defining all the steps included in that cradle to grave. That is the meaning of system boundary. So for example, getting the raw materials, then processing it because raw material will not be used as it is, then doing, if it's a ceramic mug for example, and you'll be doing all the whole different steps of pottery making, then packaging. Pottery making itself will have several steps, of course, then packaging, then finishing, for example. There may be something else on top of packaging which you need to do for readying it for transport, and then transport, and finally sale, right? So this is cradle to gate, meaning gate of the user who's going to use it. So these are this when you define all the parts included in that product's life cycle, which parts of the life cycle I mean to say, from birth to the time the product is sold to the user. When you define all of these, this exactly is what we mean by system boundary. So this is the meaning of system boundary. When you define all these, I've just put them as bullet points here, but in reality, like of course, this will be more like a flow chart, like you've seen in your slides, right? So this is just for speed and for simplicity's sake, I've put these in bullet format. But you can do it properly. You can make a flow chart and see because in all of these steps, there'll be some inputs, there'll be maybe some outputs. So all of those things you'll be doing, but I'm just telling you that defining all these steps and what all, now in this, there's only one cup, so there's not like a whole lot of confusion, but in some other very complex products, you need to define to what extent you're going to include steps or include materials. For example, like something like a mobile phone, and like it has like maybe 100 other items inside it. It must be having like 15 types of materials, must be having some other components. Those components are made up of different materials. So till what detail are you going to drill it down? Like, do you want to go through the birth of every component inside the iPhone, or what? So those steps and sub steps and sub steps have to be defined in the system boundary. For example, like if you're directly making something for the iPhone, and it's not it's made by Apple themselves, and it's made their own factory, then it's included, for example, in LCA. But maybe some other screw which is coming from China is not included in LCA. As in, it's included, but only as a screw. You're not considering the whole process from the birth of the screw itself. Am I making sense? Are you understanding what I'm saying?
Yes, ma'am.
Okay. Others?
Yes, ma'am.
Okay. So that decision is up to you. There's no good or bad or right or wrong in it. Even after defining, say, cradle to gate, these decisions are still up to you, up to the person who's doing the LCA. But you have to define it. You have to detail it. And then if you, for example, if you decide that you're only going to do it for these parts and not these parts, then you need to explain why, or you need to explain why not, right? Generally, in your report, LCA report, you will have to give a detailed description of all of these things. So this is how you define the system boundary, basically, right? Spatially and temporally. Then we come to the functional unit. So this is where we were initially. So now functional unit kind of makes a little more sense, because what we are doing in defining the functional unit is basically we're trying to do we're trying to find a way of finding an environmentally sustainable solution, right? See, the most important part of an LCA is that we are trying to find what is the way to make some item, some product, something more environmentally sustainable, right? At the end of the day, that is generally our goal. Now, what is the specific thing we're looking for? We can define in a goal and scope, and then we can define which environmental variables we want to calculate. But broadly, that's what we want to do whenever we do an LCA, right? We want to find out how unsustainable some product, some service, some building is, and then we want to identify all the ways in which we can make it more sustainable, right? So functional unit is very important from that standpoint. So before we define the functional unit, we need to actually identify what is the function we need performed. For example, if it's if it's like, say, a bottled water storage system, like, PET bottle, some other type of bottle, or some other system of storing clean water. If you're trying to find the most sustainable solution, or most of the times, we will be trying to compare different solutions, right? Whether we think a plastic bottle is better, or do we think um, that a glass bottle is better, or do we think that a big water ATM is better, or do we think that just let's not give people any bottles at all, let's have them bring their own bottles? Is that better? So we're see, at the end of the day, it's not that we will have only one solution, and if you have only one solution, there is very little there's very little to discuss. You will generally want to compare. Even if you have one solution, you may want to vary the materials, composition of the materials, design of the materials, and see which solution is better. So how do we decide better and worse is the question, right? We need some yardstick, some common metric which we can use to decide whether one solution is better or the other solution is better. Right now, if everything is varying, like in our general LCA problems and solutions, generally most of the items are varying, right? Everything is variable. So then how do you decide? So functional unit serves that purpose, that kind of a yardstick or that kind of an you know uh, common factor in all the options, so that you can decide that for one functional unit, this particular solution gives this much emissions, this one gives this much emissions, this one has this longer life, etc., etc. Now I'll just explain what I mean by that. Let me go to this one. Okay, can you see my screen?
Yes,
Yes,
ma'am.
ma'am.
Okay. So a functional unit basically defines the primary function of the product system being studied and provides a clear basis for comparison. I think this definition is sort of a bit self-evident now. And it's a quantified measure of the function of the study system, which means that we're trying to quantify things here. We're not interested in just a subjective and discussion and a subjective analysis and, you know, they're just saying that, oh, this is good, that is bad. No, we're trying to actually quantify things. And in that quantification process, the functional unit is basically making it easy for us to keep it consistent across different materials, different flows, different items. For example, even if for the same product, I decide to do cradle to grave analysis, cradle to gate analysis, cradle to cradle analysis, farm to gate analysis. I do all the different types of analysis defining different system boundaries. So even in that case, if I want to compare, I still need some basic comparing, some basic consistent unit which I can use to compare all the three or all the four methods, right? So that is what is functional unit. Now, for example, like I was giving the example of drinking water. So in drinking water, we can think of per bottle or um, per item. But what happens if I don't ask? If I don't give people a bottle at all, like in a conference, if I don't give people bottle at all, I just ask them to bring their own water bottles. We just give them water alone, or we can just serve them water in tumblers, and we ask them to drink from their tumbler. Right? We could do that. So the question is that it's very difficult to just identify one unit of the product as the functional unit, because that doesn't always work. Because sometimes I may not want to give a product at all. It may be a service. So if you're in a conference and there are, instead of giving them water bottles, plastic water bottles, we just decide to give them all tumblers, nice fancy tumblers maybe, and we just get somebody to serve them water like how you are served in a restaurant. So what's the problem with that? So there's no product there, right? You're just giving people water. So in that case, how do you compare the environmental impact? One bottle and one tumbler are two different items. You can't compare the two in the same way, right? So in that case, we define the functional unit basis, what is the most primary function being served by all these products and services, all these options which we are trying to um, use to solve the same problem. So in this case, what is that problem? Giving potable water. Potable water is drinking water. So this means that when you are trying to find sourcing or purification method, actually this example was more for purification or sourcing method, but it also applies for serving water. So for example, like if you but it goes for all. So if you are trying to see different methods of purifying water, or different ways of getting water, or different ways of packaging water, so you can water purification or sourcing is in addition to that you can add packaging also. So sorry, my cat might walk in between sometimes. So in all of these scenarios, 1 liter, if you take 1 liter of water, then that is still pretty consistent. All of these can be understood if you take 1 liter of water as the functional unit. Does that make sense? Is it becoming any clearer, or is it becoming more confusing? Yes? No?
Can you just explain that again, like why, which is more, I didn't get your idea, which is more good, like well, portable or the bottle in this scenario?
I'm not giving a comment on which is better. That is not the point here. I'm just saying that you're comparing different methods of serving somebody water. I'm not telling you which is better because I don't know. That is what you are doing the LCA for, right? Only when you do the LCA can you find out which is better, whether bottle is better or tumbler is better. The LCA is only a method to understand which is better. How can I give you the answer without first doing the LCA on which method is better? I'm just saying you cannot even compare two solutions unless you have something consistent between them. I'm just saying that you cannot compare apples and oranges. So if you compare 1 liter water bottle and 1 tumbler of water, that's an apple to orange comparison. Because they're two completely different identities. It does not mean anything if you compare the two. What you need is a consistent unit across all the different solutions. So you can say that, okay, for this much water, like I said, that the functional unit will be 1 liter of water. Right? 1 liter of water is a functional unit because the function we're trying to serve is give people 1 liter of water. Right? So if we take 1 liter water as a functional unit, then you can do the LCA basis that for all the different methods, and then you can say that for the glass bottle per liter of water, this much is the emission, this much is the this, blah blah blah. For the tumbler per liter of water, this much is the energy consumption, this much is the emissions, blah blah blah. Then you have 5 different objects, 5 different ways of serving water, and you're comparing all of them. You're stating the output, you're stating the results for all of them per liter of water. Are you understanding what I'm saying?
Yes, ma'am.
Okay, others?
Yes, ma'am.
Okay, so that is what I was trying to explain. Okay, maybe I'll take a few more examples. It should become clearer then. So now, for example, like if you have recycled paper versus normal paper versus maybe some other type of very premium kind of paper, something else, different brands of paper, and you want to do a comparison to see, which has a lower environmental footprint, or which is more efficient. So there are different types of papers these days. They're not recycled paper, but they're made of other materials. Like there are papers made of bamboo, and there are papers made of pulp of something else other than trees. like rice husk and all these type of items. They make some pulp from that, and then they make paper from that. So it's not recycled paper, but it is just paper made of alternate materials. So say suppose you want to compare the energy consumption, the environmental degradation, all of that for different types of paper. Now, if you compare different sizes of paper, like if you take one size of paper for recycled paper and another size of paper for bamboo paper, another size of paper for normal paper, copier paper, then you can't compare. You can't say which is better, which is worse, because one you're reporting for letter size, another you're reporting for A4 size, another you're reporting for something else size. You can't compare, right? Again, it becomes apple to orange kind of comparison. So what you will do, you will take a functional unit which is common to all of them. A4 is the most popular paper size. So you will take, say 1,000 or 100 sheets, A4 sheets of paper as the functional unit. When you take that as the functional unit, then you report all the outputs, all the emissions, all the environmental indicators, everything. You report per 100 sheets of A4 paper or 1,000 sheets of A4 paper, depending on the quantity for which you're doing the analysis. Does that make sense? Is it clearer? Okay.
Yes, ma'am.
This is the third example is, for example, like a light bulb. So in a light bulb, again, if you're comparing your normal light bulb with LCD, LED, with something else, the tungsten filament, there are new bulbs these days which have different kinds of they're rechargeable, and there are solar bulbs, all different types of bulbs. Now, again, for all of these also, you can't compare them unless you keep one common unit for all of them. And all of these bulbs also may not have the same wattage, may not have the same um, intensity, may not have the same temperature, may not have the same life, for example, also. So what do we do then? We need to standardize something. So when we're picking a functional unit, we are more or less sort of standardizing the whole thing, that this is some factor which we can say is common or is going to be common between all of these bulbs or all of these products, if you want to take it in a more general way. And then we are going to calculate these, all these environmental factors, all these footprints, everything we'll calculate for this particular standard which we have established. And that standard is only what we're calling as functional unit. So in a bulb, the example is like, you decide so many hours of lighting. So for example, we're taking 1,000 hours of lighting here, but it can be 100 hours also. That's up to you. At a particular luminosity. So luminosity is given as, so we take, say, suppose luminosity as 800 lumens. So for this particular specifications, how much is the energy used, how much is the other materials used, whatever. Right? Mainly it will be an energy comparison, but still there may be something else also, the materials used in the bulb and all that kind of stuff. So, and you can of course see how much is the environmental impact for this particular standard for all the 3-4 options you have. So then when you compare them, you can actually decide which one is coming out to be better. Again, unless you do the LCA, you can't say which is better. You can only decide that after doing the LCA, right? Is this making sense now? The functional unit?
Yes.
Okay, so this is some of the for these are some important examples which could be helpful for you. Now, coming back to the lecture, there was some other, I think, similar term, just designated unit. Think. Yeah. So I'll come to the designated unit. Another important point here is that in a lot of these products, we may be doing something like a very long analysis, like a cradle to grave or cradle to cradle analysis or something like that. So then in that case, you also need to often give a time unit in the functional unit, in the sense that you can say this much. So suppose we have something like a carpet. You can say that the functional unit is per square meter of carpet per year. Because say suppose that carpet is being used for a very long time period, or multiple people are using it, or maybe it's a product service system. So you're never actually throwing out the carpet. You just keep replacing it, you just keep reusing it, or things like that, right? So if things have a very long life, and if we may have even designed them to have a very long life, so in those kind of cases, you ideally should also specify in terms of timeline. For example, like the carpet example, if I take 10 different types of carpets, right, and they all have a very long life, and they all have a very long life, but not the same, right? Some carpet may last 10 years, some may last 15 years, some may last 25 years, right? They have long life, but they don't all have the same length of life, right? And so suppose some require more maintenance, some require less maintenance, some requires more repairs and replacements. Then even though they all have a long life, still there are still differences. That's why you want to do an LCA to see which is more environmentally beneficial. So in that case, if you don't specify something like per year, then again you are leaving the whole field wide open, and there is very little basis for comparing the figures from one example to another example, right? Because one carpet may be consuming very little energy or very little cleanliness and maintenance, and it may be lasting 25 years, uh, and another may be using less maintenance and energy but may be lasting only 10 years. And if you compare the two, how do you know which is better, right? Because here it is 10 years, there it is 25 years. You can't directly say that this is better, right? Because you've not included time as a factor at all. You've just looked at the final number. This is 20, this is 22. Now, how do you compare the two, right? Are you understanding the problem? Is the problem statement clear? Has everyone run away?
No, ma'am.
You understood the problem statement? If it's not clear, let me know. I will explain again.
No, no, ma'am. I didn't.
Okay. All right. Just give me a moment. Oh. Sorry, just give me a moment. I'm trying to log in. Okay. So I was trying to explain how, say, suppose you have two, three, or any number of different types of carpets which all have different life length. So this is carpet one, okay, or let's call it A. Carpet B. Mm, okay, they're all different types, different qualities, different texture, different types of carpets. And I don't know if you people remember the example from your assignment where people don't buy the whole carpet again. They just have a tile of the carpet replaced or repaired by the company if needed, right? So say suppose, do you know that assignment question in your assignment? It was there, I think, in assignment number 2.
Second.
Yes, Ramesa.
Yeah, yeah. So this is, say suppose some of these are like that. Some you have to buy the whole carpet, no other option. Say suppose D is PSS. Okay. The others are normal carpets. This carpet has a time, like, length, life of 25 years. This carpet has a life of 10 years. This carpet has a life of, say, 12 years. This carpet, suppose, has a life of 35 years, right? I've just, put arbitrary numbers, but this is kind of what happens when you buy carpets in the market, right? They don't all have the same life. They don't all have the same quality. They're all different quality carpets. And of course, they would all be costing differently also. They're made of different materials. They have a different type of environmental impact. But in the end, after, say, suppose you do LCA, perform LCA, and you say that, and you report answers in 1 meter square of carpet. They're all different sizes, of course. So you say per square meter of carpet, right? Now you've said taken the per square meter of carpet for each of these, and you're doing a cradle to grave, right? Now in cradle to grave, it covers everything. Now for all of these, I've put this 25, 10, 12 years here on top, but we don't know what the actual life of the carpet is. When you're buying a carpet, you don't actually know how long each carpet will last. You may have some idea, rough idea, but you don't actually know those things, right? This much is clear so far, so good.
Yes, ma'am.
Yeah. You may have some idea that this will last longer, this will not last that long, whatever, but you don't know exact number of years it is going to last. I'm putting this just for our explanation purpose. Now, you do the LCA and you report the emissions, usage, pollution, blah, 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 whatever, for each of them. But how will you compare? So suppose this one has 2 kg emissions. I'm just making up the numbers right now. This one has 3 kg, this has 2.5 kg, this one has 3 kg. They all have similar emissions, I suppose, in the analysis. How will you compare per square meter of carpet? For carpet A, it is 2 kg. For carpet B, it is 3 kg. For C, it is 3.5 kg. For D, it is 3 kg per square meter of carpet. Are they all comparable? Is it the same? Are they all almost equally good?
Equally good.
Sorry,
Equally good.
how is it equally good?
No,
You
it
can,
is not. It is not equally good. Can be
okay.
compared.
So why is it equally good if you think it is, and why is it not equally good if you think it is not?
Madam, here the life of the carpet is not considered.
Yes, yes,
Yeah.
you are correct. I
Maybe-
wanted her to answer. That's
Yeah.
all.
Maybe one carpet may be taking 3 kg emissions, but 3 kg emissions, if you use 20 years, may be better than 2 kg emissions in 10 years.
Yes, you are correct. I was talking to her because she was having trouble understanding that
Okay,
concept.
madam. Okay.
Yeah, yeah. No, you are correct. I was asking her because she was answering. That's why, and I wanted her to explain her thought process so I can help her understand a bit better. But is it clearer now?
Yes, ma'am. Because in 35 years, it is emitting only 3 kg. So, and
Yes,
then the 12 years, it is emitting 2.5, and 10 years, it is emitting
yes.
3 kg. Yeah.
Yes, that is the point I was making earlier. I think with making the diagram like this, it's a little bit clearer. So as Gopalji was also saying, uh, that is the point I was explaining, that this is why when we take the functional unit in the case of something like this, which is in which we are dealing with all varying time lines or varying length of the product life. When time is the time as a quantity figures in the LCA because it is varying a lot from one product to the other, or because the emissions, etc., are varying a lot with time, then in those cases, it's just always a better idea to include some unit of time also in the functional unit. So, in this case, but you can see very outright that life length of life is different options. So including the unit of time is also important in the functional unit is important. Right, so instead of just taking 1 meter square of carpet, we'll take 1 meter square of carpet per year, right? This is what we'll take as the functional unit. Then you can compare and see that, okay, we are seeing that in this case, then what happens to the value? This becomes 2 by 25. This becomes 3 by 10. This becomes this becomes this. You can calculate each of these and see what values you are getting. And then you can, of course, compare and decide which one comes out to be better. Like, okay, I'm not really feeling up to doing all this arithmetic. You can do it yourself. But I think this one, product D, is going to be most probably the better one, right? This will be something like 0.2, this is 0.3, this is also something like 0.1, this is something close to 0.1, but I think 3 by 35 is smaller than 2 by 25, right? Am I wrong? Right. Would somebody calculate and tell me?
Correct. Yeah, it is 35 US.
Yeah, so 3 by 35 will probably come out to be the best option in all of these. And then you can think about, and that is so because I chose that to be the PSS system, because its life is generally much longer, right? That is how you can see that in a PSS system, just by elongating its lifeline itself, sometimes you can improve upon. I mean, I was just trying to make that point.
Madam, there is another factor we always get confused. That is the system boundary, cradle to get. So, is it with reference to producer or consumer? Can you just throw some light on this vocabulary? This,
Okay.
uh,
So it's not in relation to any particular like user or producer. A cradle to cradle. Okay, let me just explain it with a diagram. So system boundary is like a very important concept actually. So say suppose we're talking about a coffee mug again. So actually I was discussing this before. I think you joined the class. I explained system boundary in quite a bit of length. I'll explain it briefly now, but I'll suggest that once I upload the video, if you can just go back and see the part where I've explained the system boundary again.
sure, madam, sir.
Yeah, it's okay. I'll explain it in brief because your question is slightly different. But when we are picking any product, so suppose just a coffee mug, right? Assume for now, let's assume it's made of ceramic, pottery mug. Then all the different options we have is cradle to grave. This farm to gate, but in this case, there is no farm, so farm doesn't matter. There can be other options also, but these are the most common
Gate to
ones
gate,
which you,
gate to
you
gate.
can, okay, you can do gate to gate, but again, in this case, gate to gate doesn't really make a lot of sense. So some, some boundaries will not be applicable to certain products.
Why can you?
Sorry.
Yeah, basically the reasoning why, which one is applicable, how to judge? Yeah.
Because if it is not, there are no two gates in your product, then it won't be gate to gate.
So
So
that
there
is
are,
applied only in factories, right? Gate to gate.
not necessarily factories, but say suppose you have some raw materials or some other input materials being assembled somewhere else, and then from there it's coming to some other factory where you're manufacturing the product. Then you can say gate to gate, that from there to here, and then it's leaving from there uh, say suppose the product, the user's house, for example. Okay, let me draw it. It's not clear like this. I'll come to that. Let me just go step by step. Gate to gate comes much later. So let me just explain the simpler one first, and then I'll come to the more complicated ones. So say suppose it is cradle to grave. That is pretty simple, that from everything from birth to death. So you have raw materials, procurement, right? And then processing of raw materials, then you say suppose assemble or making parts. So if it has parts, and I'm just taking a very simple example. That's why, because if you start with a complex thing, you can't understand everything very well. So in this case, there is no part here, right? So I'm not talking about parts for now. Then you actually manufacturing, which means in this case is pottery, making the pottery. This itself will have like 3 steps or something. Like you first prepare the material, then mold it, then you dry it, right? Then you glaze it, then you finish it, then you package it, you transport it, then it reaches the user, and then the user uses it, then it's discarded or upcycled or recycled, whatever. So this is like the overall, everything that happens, uh, everything that you can say in a very brief way, what is included in cradle to grave in manufacturing a coffee mug. Now,
Madam, just one confusion. The last one should be grave, no? Grave, but again, recycling is not grave. Grave means I am understanding that it is going back to the earth. No?
sorry. No,
Grave
so
means
cradle to grave, I'm just saying that in the end, these are all the options of what can happen to it. If it
but
is recycled, yeah, even if it is recycled, you can do cradle to grave analysis for a recycled product only. You're just not considering the part where it goes into recycling.
okay. I was under the misconception. Grave means going into the landfill.
No, grave means end of the life cycle of the product. So here the product is broken, for example. I've chipped off the corner of the mug. I can't use it anymore. Now that is end of the life cycle of the product itself. Now if you want to recycle it further, then you can recycle it. If you take it cradle to cradle, then that becomes a recycled product analysis again. But if you're taking cradle to grave, then it is end of life for the product here. You need not consider
One,
the upcycle or recycle part.
now one question, like normally the mug can be reused also, right? So
Reused in what way?
it can be washed and reused.
So of course you're washing it and reusing it here. This
No,
is
what
all
I
there.
am no, I am asking like if you are using it, won't be in the grave, no, cradle to grave.
No, I also feel
Sorry,
it
what?
is a,
I got always confused last assignment the same thing because it is reusing, like, and it has to the even example of glass bottles, it has to go back to the manufacturer or whatever it is, again filling and coming back. So there is a cycle happening, right? So that is just a confusion.
So see, after the product is spoiled, you can do whatever you want with it, but it will not be included in cradle to grave analysis, is all I'm saying. Cradle to grave means when the product is dead.
no, a dead means it should be discarded. It should not be upcycled.
No, that's not what it means. Upcycled or recycled is a possibility even after the product is destroyed, right? You're just not including it in cradle to grave analysis. You're just not including the recycling part of it in that analysis. That's why I've just said I've left the loop here. I've not continued here. If you want
Okay.
to continue this further, you can continue it further. You recycle, you upcycle, you do whatever you want with it. You make a brand new mug out of it. You can do all that, but that is not going to be all. The grave ends here.
Okay, madam, I got it.
This is grave, right? So I mean, it's a very ugly example, but there are people who also allow their bodies to get composted, who also donate organs to other people, but that does not make the person go back into life, right? Grave is still grave, the body is still dead. It's similar example which I'm giving here. You can do whatever you want with the remaining mug, which is now ruined, broken, whatever.
Okay.
But the grave and the cradle to grave analysis ends here. After
Yeah.
this, whatever you're doing is good, but it will not be captured in cradle to grave analysis.
Okay. So here the grave is
Understood.
the end of useful life. Over.
Yes,
Right.
yes. Because I'm not saying that I just decided to stop using it. I'm telling you that the product is spoiled here. At this point, the product is spoiled.
Okay, ma'am. Go
Okay.
ahead.
Okay.
Got it.
Yeah,
Okay.
so that is the meaning. That is why that is why I said that not all methods are the best fit for every kind of product or every kind of analysis. Because in some of the analysis, your method may not capture all the aspects of that product itself. For example, like the example you're giving, where you're recycling it or upcycling it, even after the mug is broken, I can use its parts and make some other product for some artifice, something to put on my desk so it looks pretty, or I may decide to grow a plant inside it. I can do many things with it. But that part of how I'm reusing it or recycling it is not captured in cradle to grave. That is why it is always good to think about which method is the best fit for your particular product. It may not be the best fit for some product, or it may be the best fit for some other product. So in this case, if you are clear that you are recycling, upcycling, doing something of that sort, then it's better to take something like a cradle to cradle kind of an analysis. That will help you at least capture all the good, aspects of your product also. Okay, is that helpful?
I got one more question. Maybe it
Yeah.
is not making any sense. But I'm getting confused from last assignments and the reading materials. So
Okay.
if we are having one particular function, not function, this system. So they might be having different cases. That means system boundary. Is that correct or wrong? What my understanding?
Sorry, what is
So
having
for
some different?
example, if it's a glass bottle, the manufacturer it is making and it is transported and it is reaching into the user, and again it is washing and distributor collected and using, and it is and again one point it is end of life. That is what I have read because I made a flow chart with the reading material. So in that I understood the manufacturing and transportation, and it is going to the coming to the user, and then user somewhere it is collecting and washing and refilling, and then again coming to the distributor and user. So then some point it is going to the end of life. So there
So
will be
what is
some
the
different.
question?
Question is in one life cycle there will be some different system analysis.
I'm not understanding your question actually, what you're trying to ask. What I'll do is I'll try to find some other reading material for you guys. I'll share a handout or something. And okay, let me also check since you're asking me this. I don't remember
Well, my
exactly what
question
part
is
you're
system.
referring to. Yeah,
Yeah.
sorry, go ahead.
So maybe one part it will be the cradle to grave. If you look into the manufacture to the end life, might be the cradle to grave. In some part, it will be the cradle to gate. That is what I felt. Maybe
No,
maybe
it
wrong.
can't be that one part you do this, one part you do that. That is, you can't do that. You have to do the same process for the whole product service system.
Okay. Okay.
So if you're like, your thing may have several components. This is one component, two component, three, no, four components. Now say suppose up till cradle to grave only this one matters, the others don't matter, then you put zero,
Yeah,
right?
that is what I mean.
If
Yeah.
this is going till cradle to gate only, it's not playing any role after that. For example, this is also going only up till gate, only this and this one are going up till grave. Then you keep adding for this one and you ignore these two for the grave part, but the whole report will still be cradle to grave. It will not be cradle to gate. You can't
Correct.
report that this is only for cradle to gate and these two I'm doing for cradle to grave. You can't do that. You can't mix the two like that. You understood the difference?
Yeah. Got it. Got it. Yeah.
Okay, and since there's so much confusion about it, let me also like read it once and get back to you again in case I have made any mistake. I don't think I have, but uh, since people are getting confused, I just want to make sure I have answered you correctly. Uh, any other question, please let me know so I can look it up. Actually, I have been down with the flu, so I don't think I'll be able to sit for too much longer today. So I would, if this part is clear now, then I would like to end the session in a few minutes. But if you
Hello.
have, yes,
Hi, ma'am. Myself Kunal. So, I'm sorry, actually, I haven't been to the previous course material. I've just joined just now. But from
okay.
this explanation, what I'm getting, what my doubt is that, so let's consider the same example of the mug. So, if I'm working with the manufacturer, so in that case, my analysis will be cradle to grave, because when my production ends, basically my analysis should end there, right? Or should my analysis also cover the point where uh, I'm considering the uses of the mug, or when should be
No,
recycled?
your cycle doesn't end based on who you are. The analysis is decided based on a very more holistic framework. It's not decided by based on like if I'm the user and I'm doing it, then it should end with me. If I'm the producer, I'm doing it, it should end with me. It doesn't happen like that. That's the whole point of system design. You
Okay,
think beyond yourself.
right.
The product has a life much beyond what your vision may end
Mhm.
at some point of time, but the product continues to impact the environment after that also, right? So
Okay.
that is how you make mistakes, but just because you are a producer doesn't mean your job finishes after selling the product. You
Mhm.
have to consider, and like I said, there are different methods and they're all meant for different purposes. Sometimes people do cradle to gate because they want to compare different products from cradle to gate, because after gate maybe it is very similar for all of them. So in that case maybe cradle to gate is a good methodology to compare five different types of products whose manufacturing processes are all very different. You understand?
Mhm.
So you have different methods for different purposes. But it's not that because you're a producer you will do only cradle to gate or something like that.
Okay, got it.
Okay.
Thank you.
It'll be helpful if you go through the course material. It'll take some time, but your questions will, I think, what you're asking will get clarified if you go through the course material.
Yeah, yes, ma'am. Yeah.
Ma'am,
Okay.
I have a question.
Yeah. Yes.
Third question from the last assignment. It was asking for
Can I
one of the
stop sharing
parameters.
this?
Yes, ma'am.
Okay. Uh, Sorry. Wait a minute. Question which assignment? Three.
Yes, ma'am.
Okay.
Like we discussed, the system they asked for was cradle to grave. That was the second answer. Then from the third question, if it was cradle to grave, then it should have been the chain. But they told it can be the chain and the tree. So I only got half mark for it. So my question is, if we are drawing the flow chart, if we are understanding that one thing is like getting recycled and going back to the material stage, then that is where the difference is between train and no chain and tree. Tree, you are not taking it back. So why is it still tree? Is my doubt.
Because, 1 minute, let me read the question. LC boundaries cradle to grave. No, they are all different representations of the same diagram. You can think of it as chain or you can think of it as a tree. That's all it's asking. It's not asking about direction of movement or anything like that. She's explained this in the lecture actually.
Yes,
So in
in
the
the lecture, they
lecture,
are taking the example of
yeah,
pet bottle.
yeah. So in the lecture, there is an example in which she's just explained that the system can be defined as a chain or a cycle or a tree, whichever, depending on uh, the whole thing. In this case, the cycle will not be there because there is no cycling. But chain and tree are both just interconnected ways of looking at it, right? So chain and tree are both correct. See, chain just means connecting links. Tree also means from one to the next branch to the next branch, right? Both are happening in this case. Only that cycle
Yeah.
in which that closing of the cycle is not happening because it is not cradle to cradle. Is it? Did you understand?
Yes, ma'am.
Yes, ma'am.
Okay. So I'm sorry, I'm just coughing a lot and I have fever also. So I won't be able to speak a whole lot more today. But I will go through all your questions and I will share some handout with you for reading, which will hopefully make it a bit clearer for you. And we'll meet again next week, same time. In the meantime, if I am able to, I will upload some sample questions also. Please look into that shared folder. You know where to find the shared folder, right? For every week's
Yeah.
content.
Yeah.
Okay, all right. Yeah, I'm sorry I'm not able to sit for the whole 2 hours today, but I tried. Okay, so is it okay if I end the session here? Any other questions?
I have one more doubt. It's the
Okay, yeah.
marking system, not the lecture.
See, marking, I can't do anything because I don't know how that is done and I don't have any access to changing
Madam,
anything.
Madam, post everything on the NPTEL problem solving folder.
Sorry, what? I didn't understand. Sorry, say
Yeah.
again.
No, whatever you post material, please post it on the same NPTEL folder, no?
See, I don't have access for that. If you want that, you have to tell the NPTEL team. I don't have any special power or anything with the NPTEL team. I'm just glad they put it even one link there. They weren't even adding that in the first week. I don't know why. So I don't know why we get this kind of a stepmotherly treatment, but they have just put that one link there on the NPTEL platform from where you can find the link to the folder. That problem solving session, that thing is uh, it's that shared Google folder. I'm just sharing the link here. You can save it, please. Please save this link. It has all the content. I can't ask NPTEL team to do much. I mean, I can ask, but they may or may not do. So if that is it, can I end the class here?
Yes, ma'am. Thank you.
Yeah.
Thank you, ma'am.
Okay, all right. So I'll be here next week and I'll share some reading material and practice problems. I'm sorry I'm not able to sit longer. But hopefully I'll be fine by next week. So we can stretch it a bit next week if needed. Okay, thank you everyone. Thank you for joining.